In this question, there is a block of mass m kept on a table. Okay, the frictional coefficient between the table and the block is mu. So this is a table here, and now it is said that when a horizontal force is applied on this block, it slips. Okay, but the table is stationary. Table does not slip. Now they are asking what is the frictional force applied by the floor on the legs of this table. So these are the legs, right? So let's look at this first. So small m is slipping on a rough horizontal table under the action of the horizontal force. Okay, so now the frictional force on the small m will be mu mg. Since it is slipping, there will be mu mg force towards left. Why mu mg? Because the normal reaction is equal to mg, right? Okay, now since the frictional force experienced by this block is mu mg, the frictional force on the table by this small m block will be again the same but in the opposite direction. It goes according to the laws of Newton's third law of motion, right? Every action has an equal and opposite reaction. Now the table is not moving, right? So if I draw the free body diagram of table, I can see there is a forward force mu mg, but it is not moving. That means the backward force is counterbalancing this mu mg. Now let's say the backward force is what force? Basically the force by the floor on the table, right? Table's legs, the legs of the table. So that let's call it f dash. Now f dash has to be equal to mu mg because there is no acceleration in the table. So that means f dash is equal to mu mg. The frictional force by the legs is mu mg, that is towards left. Now they have asked again that do you need the frictional coefficient between table and the floor? The answer is no, we don't need it because this mu is sufficient.